see a 1 million GPU cluster opening up sometime in the next 3 years. Kate Soul is a director of technical product management at Granite. Kate, welcome back to the show. What do you think?
No, I really don't think so.
Anthony Annunziata is director of AI Open Innovation. Anthony, welcome to the show for the first time. What's your take?
I don't think so either.
And then we've got a very special guest. Naveen Rao is VP of AI at Databricks. I think our first external guest on Mixture of Experts. Naveen, what do you think?
Unlikely. I think there will be a reset in terms of expectations, ROIs, and that's probably going to drive a little more rationality into building these out.
All right, all that and more on today's Mixture of Experts. I'm Tim Huang, and welcome to Mixture of Experts. Each week, MOE brings you the insights you need to navigate the ever-changing, ever-unpredictable world of artificial intelligence. Today, we're going to be talking about 2025, what the future holds for agents, what the future holds for AGI. But first, let's talk about the future of scale. AI companies have basically been chasing scale, unless you've been living under a rock. That won't be something that's unfamiliar to you. And kind of where that has been most prominent has been in data centers and power. McKinsey just came out with a report that estimated that global demand for data centers could triple by 2030, with generative AI driving huge increases in energy consumption. And their estimate, which is mind-boggling, right, is that spend will be $250 billion for this infrastructure by 2030. And so I guess maybe, Kate, maybe I'll kick it to you first. Can you give our listeners a little bit of intuition for why all these companies are chasing scale and why that's been important to the history of AI so far?
Yeah, sure thing, Tim. So if you think of how these models have trained and evolved over time, it's basically been a really simple formula of taking as much data as you can get, adding as much compute as you have access to, and training a model for as long as you can afford it in order to maximize performance and send that out. So, to date, the recipe for scale has been a mixture of getting more data and getting more compute. And obviously, that's going to continue to drive costs and potentially drive demand for data centers. I think there's going to be some interesting things that start to emerge, though, that are going to maybe break some of the trends that we're seeing. For one, we're just running out of data. We're seeing all the data is being, used no matter the model size. It's no longer scaling proportional to size, and there's only so much data out there that's worth training. We're also seeing a lot more compute being starting to spend at inference time instead of just training time. So as we continue to max out what we can pre-bake into the model as it starts to train, we're starting to see, are there other places, like when the model runs inference, that we could spend some extra compute to try and boost performance? So that also might start to break some of those trends.
That's great. Well, Naveen, maybe I'll turn to you, because I know in your opening comment, when we were talking a little bit before the show, you were saying that, hey, look, maybe scale is not all you need, right? And that we're going to have to kind of really evaluate how we do machine learning. And I guess maybe to kind of take Kate's comment there, why shouldn't we believe, it's been working so far, why shouldn't it keep working, basically? It feels like, we've had these huge successes just kind of doing the dumb thing, which is add more data and add more compute. Why is now different, right?
Well, I think you also got to look at the motivations. I mean, I was a scale maximalist for a long time. I mean, I started the first AI chip company back in 2014, and we built it for scale from day one. It was designed to be a scale out sort of a thing. And I'll offer a different explanation. I mean, yes, everything Kate said is correct, but there's also another motivation. As an engineer, it's a really freaking cool problem to scale something bigger and bigger and bigger.
It's just cool.
It is.
People want to work on it.
And I've been seduced by that myself. Oh, this is cool. I want to build that, And there's interesting challenges that get presented each time. The latency starts to matter. How do I deal with that? Can I come up with new strategies? So it's one of these things that's it's like an intellectual pursuit. I'm going to keep going bigger and bigger and bigger. And it is a cool problem. It is a fun problem. But at some point, you've got to solve problems not just for their own sake. And I think that's what we've come to now. I mean, like Kate said, we have run out of data, but also the paradigm of simply trying to train on more data isn't going to yield more results. And I'm happy to go into why, because these things are essentially conditional probability estimators, and you can never uncover every conditional probability in the data you have. You will. I've said it many times. You will get to the eventual heat death of the universe before you will uncover all of those. So I think there is always going to be some return from getting bigger and more data, but like it's diminishing for real world applications. So you need a new paradigm.
Yeah, for sure. And do you want to talk a little bit about what you think that new paradigm is? I mean, in some ways, that's like the multi-billion-dollar question. But while we're speculating around 2025, kind of curious if like you've got intuitions on, okay, if not this, like it actually turns out the data is failing us, which is kind of a crazy thing to say. But it's like, well, what comes after data, right? Data is kind of what we know in some sense. If you think about like trying to train these models.
Yeah, I think there's
tasks
there's several facets to it. Okay, so I'll say on the algorithmic side, like it's intuitive. If anyone's been around, a child learning or even trying to train an animal, you don't train it through exhaustive observation. You don't put a kid in front of every observation of how to do a task and then expect them to learn it. That's what we're asking right now of an AI model. So we actually do it through a trial and error of actually performing something, getting a reward or an anti-reward for performance. And then,
you're talking reinforcement learning.
Yeah, I mean that's a big part of it. We do some form of reinforcement learning with neural networks, to be clear. It's kind of a weak version, but it is there. So this concept does exist, but it's also predicated on this huge, set of distributions that it's been trained upon. And what animals tend to do is actually be much more efficient. They observe they build some baseline distributions, and then they act and update these distributions kind of all at once. So I think something towards that end is going to be the answer. There's no doubt in my mind it has to work that way, because this way we can be much more compact with our representations. We can actually discern causality. Causality may or may not exist from a physics standpoint, but the reality is it's a more compact way to describe how the world tends to work. Right.
Yeah,
and so I think this is something that has to be uncovered in our models. We can't make it just hugely observational. It's not going to work.
Yeah, that's super fascinating. And it's actually kind of funny to think that like the recent history of deep learning is kind of out of order, right? Like I remember in the AlphaGo era, it was like everything's going to be reinforcement learning. And then that kind of just like sort of petered out as all of these other approaches kind of had success. But almost you're saying like we kind of got to get back to that. Like that's actually maybe the key,
I actually think AlphaFold and AlphaZero were very much on the right track. I think we didn't have the scale part figured out yet. But honestly, I think it was the right approach.
I'd present also a complementary perspective, which is maybe a simple one. So research is hard. Research in AI is hard. When you find something that works, people jump on it and they run, right? So what happened a couple of years ago is that. And when that happens, there's kind of irrational exuberance almost, right, in the research community. Sometimes we think decisions are made more deeply than that, but sometimes you just find something that works and you push it as hard as you can until it stops working as well, or until other things catch up, including, cost and ROI.
100%.
Yeah, for sure. And I think what's interesting, I mean, your title is looking at specifically open innovation. And I do think that is one thing to talk a little bit about is, traditionally, and by traditionally, I mean like last 36 months, right? Like a lot of the breakthroughs have been, you have access to this really big computer that no one else has access to. And I guess, I don't know, Anthony, if you have predictions about how these dynamics change, right? Like if scale is no longer the thing that really gets the breakthrough, are there just more opportunities elsewhere now? Like there's going to be more people who can do, kind of advance the state of the art here without necessarily having to have access to a million GPU cluster.
Yeah, I think so. Just taking a little bit of what Naveen was saying. Innovation at the architectural level, innovation at the feedback level, innovation in how AI systems are built, like there's a huge opportunity for that in the open community, in universities, in players that I think have been left on the sidelines, but have struggled to catch up with the scale story, right? Just because of the centricity of compute. I think we're going to see even more of that. I think it's really important. I think the other side of it is the product of a couple years of just pushing ahead really hard is that we have great open models out there that are very capable. And you've already seen a flourishing of innovation with them, but there's a lot more to go just with what we've built already and what's going to continue to come out.
For sure. I want to force the panel to make some concrete predictions here, right? I think one of the interesting things about scale is there's always the dream if you like flip over a few more cards, maybe the model is just going to get that much better. And so like it feels like this kind of like the gas could run out of the scale car before we realize that kind of scale is broken. But I'm kind of curious, like, is 2025 the year where scale sort of breaks? Like, where we're just like, actually, it turns out that this is not going to work anymore?
I think it already broke.
You think it already broke? Why do you think that?
Show me a bigger model than GPT-4.
Uh-huh.
No one built one. And there's a good reason for it, right? They probably have built one, but it didn't do anything all that special, right?
Right.
So, and I think that's been the issue. Is I think it's already.
I asked for hot takes, and it feels like you're really delivering for us,
Yeah,
Naveen.
there you go. Right. Show me something bigger than 1.6 trillion parameters. I mean, not to say that there won't be a way that that does yield advantages, but there's got to be more to it. It's not the only ingredient. Scale's not the only ingredient. You need that plus something else, and maybe then you'll get some super intelligence or whatever you want to call it. But we haven't cracked that yet.
Is Kay, Anthony, I don't know if you'd agree, is scale already failed, right? Like, we're already living in a kind of post-scale world, basically.
I mean, I think there's an important part of the story that we haven't covered yet, which is part of the advantage of scale right now is being able to then boost the performance of smaller models. So maybe the performance of how far we can push the top of the spectrum has been maxed out to some degree just on pure size alone. But I think there's still a lot more to talk about in terms of how to scale the performance and the amount of performance you can pack into fewer and fewer parameters on the smaller model sizes, using those large models as teacher models, as synthetic data generators, as using them in RLAIF workflows in order to better improve smaller models. So we've seen a trend, right? If you look at what a model could do last year, you could do that if it took 70 billion parameters or 100 billion or a trillion parameters last year, you can do many of those same tasks in fewer than 8 billion parameters today. Don't think we've maxed out that curve of downsizing and packing more and more performance into smaller and smaller models.
Yeah, the commercial dynamics of that are really interesting because, the rhetoric has often been, we're going to train this massive model and then we're going to sell an API against it, right?
Yeah.
Like, basically that it's going to be an external phenomenon. Kay, you're almost presaging a world where like each of the big labs will have their gigantic model, but it will kind of be for internal purposes almost. It's like for minting the smaller models that really are actually where
Absolutely.
most of the commercial action
I
is.
think
Yeah,
there's
it's
like
pretty
this
interesting.
huge competitive advantage that model providers have simply by having their own in-house large model to boost and create the smaller models that everyone's actually going to use. No one wants to run a trillion parameter model for real tasks at inference time.
As
Like,
cool
it's
as it
just-
is.
It's cool. Everyone wants to say they have it, but no one wants to actually use it in real world applications, right? It's the smaller models that will be much more cost effective.
I'll offer another set of data. So I'm a neuroscientist from grad school, and I think I like to look at biology as a blueprint for many of these things because over 4 billion years of evolution, some interesting things came about. And if you look at brains, scale was not all you needed. Humans do not have the largest brains in the animal kingdom. Brains do scale with body size. So blue whales have the largest brain by mass. It's actually very likely also more neurons. Dolphins have very large brains as well. So and elephants. So there are lots of mammals that have larger brains than us, but clearly haven't had the same impact on the world as we've had. So, I mean, there are several reasons for that, but I actually argue there are some architectural differences in their brains that lead to this. And we came up with the right mix of scale, architecture, and environment to actually, build human intelligence.
Yeah, I like that. It's almost like the adage, like super intelligence is not all you need, right? It's basically like, like you might have a huge brain, but actually its impact may be actually quite limited in some ways.
Yeah. That's a whole other topic. I'd love to dive into if you want, but like, I don't even know what the hell super intelligence is, right? Like, how do we even define this? I mean, have some definitions, but I think everyone's like talking about, it's a foregone conclusion. It's happening in 2 years. Like, guys, we haven't even solved regular intelligence.
Can't even define it. First
Exactly,
of all.
right.
We can't
Yeah.
define it.
So we will definitely get to that. I guess, Anthony, maybe I'll turn to you on predictions and we'll close out this segment. I would just observe, right? Like the contracts to build these massive data centers are happening now, right? Like regardless of what's happening in scale lands, data centers are certainly scaling. So is it kind of like we're going to see in 36 years or 36 months, basically just like these huge facilities just kind of mothballed? Like we're going to have big empty data centers is kind of the future.
No, I don't think that's going to happen. I think there'll be some correction, but I think it'll be a smooth correction. Also, I think what's really important is we focused a bit on the training part of scaling, right? So the scaling of deployment, whether they're medium-sized models, small models, APIs to big models or whatnot, will absolutely depend on the availability of cloud data centers. So I think the trend is reasonable. Maybe it's inflated a bit, but I don't think it's going to like wholesale collapse.
I would agree with that as well. So if we look at, again, where there's opportunities to add something that's not scale into the equation to try and improve and boost performance, I think we're starting to see there's a lot more innovation that we can do at a single model, regardless of its scale at runtimes. Allowing it to run multiple times, generate multiple answers is a very basic example, in order to boost performance for any given inference. And if that trend continues, then we have a whole much larger population that's going to be driving up inferencing costs. And they only have to pay for their small fraction or part of it versus training, right? You have to get these big model providers to dump tons and billions of dollars into building these compute centers. But if everyone can start to see that lift and have their own ROIs that they can take advantage of, I think that's going to continue to drive the investment at inference time compute even more so than what we have today. Any given API call could, cost 10 times what it does today just because it could be worth it from a performance gain perspective.
Yeah, for sure. And I think that'll be really sort of interesting to see as you build these big data centers being like, we're going to do the mother of all training runs. And it's like, actually, like we need it for inference. So
Yeah, I think there's a whole scale story in terms of deploying AI practically that really has just started. And I think, I fully agree with Kate.
There's some parallels to the internet build out as well. Like I think there was a lot of talk around 2000 timeframe when the stock market crashed that, oh my God, did we overbuild, a bunch of network infrastructure, blah, blah, blah. And, in the fullness of time, none of that was true. It was underbuilt, if anything. But it took a few years. There was an overbuild for a short period, like maybe 2 or 3 years, until all the demand caught up. And I think you're absolutely right. That's where we're going to end up probably, is like, it's not going to be like these data centers are way fallow, but there's going to be a bunch of articles that say like everything was overbuilt, the bubbles burst, and then in 2 years it'll all make sense.
Wouldn't that
All
be a
right.
nice change? High
Yeah, for
availability
sure.
of GPU compute at reasonable prices.
I
Yeah,
think it's
exactly.
already
Just
true,
imagine.
honestly. But
It's true. It's true.
Dream the impossible dream. I'm going to move us on to our second segment. So if there is one word that has characterized enterprise and AI in 2024, it has been agents. Agents. Even on this show, it's become a little bit of an in-joke that like agents need to come up at least once during the course of the episode. And there is news out that Salesforce is planning on hiring 1,000 salespeople to support its push into the agents market. As we kind of get into November here and start thinking about 2025, I just want to ask, like, is the future really agents? Like, are we going to continue to live? Like, I'm going to have to hear more about agents in 2025. I guess maybe Naveen, I'll kick it over to you first. Is like, how do you think this market's going to evolve? And are we about to like, is hiring 1,000 salespeople justified here?
well, honestly, no, because I know the state of the art of where agents are. But it's a great headline, and that's what they do. I mean, Salesforce is great at this, and it's fine. It's going to make them try to appear as more of a big AI player, and that's what they're going for with that statement. So I think it'll serve their needs. I don't think it's actually necessary, because when an agent really works, you're not going to have to do much to sell it. Honestly, it'll just automate things, but we're not there yet, and I think that's where the hype is a little bit ahead. And again, it's going to be one of these things. There'll be a big disillusionment in the next 2 years, and then it'll come back slowly, and it'll actually be super useful in 3 or 4 years. Right? That's kind of how this is all going to work. So
Yeah, you have to join us November 2025, and then maybe then Naveen will be like, maybe.
yeah, exactly. But I think it's not you're not going to need 1,000 people to just to focus on agents. It's going to be something that's going to be amazing for the product, and people will use it, and their sales infrastructure should be able to handle such a thing. I mean, at Databricks, we have similar problems. We've actually decided, should we hire, like we've gone through this, should we hire a whole bunch of people to sell AI, or should we try to like layer it into the product? We've actually done a mix. We haven't hired 1,000, but we have hired some people. And, it comes with mixed success, because what you need to do is really integrate it into how people use the tools and make it somewhat invisible, and then it will sell itself.
Yep, for sure. Anthony, I see you nodding vigorously. I mean, maybe I can just ask you to go a little bit more. It's almost like what Naveen said is like, almost like the promises right now are not necessarily matching up with where we are. I'm curious if you've got thoughts on like where the gaps are at the moment.
Yeah, a few thoughts. So look, first, what is an AI agent? What is an agent in general? Like, there's a large spectrum of what that means. I think if you look at some of the announcements, like the one you referenced, the use of agent is kind of a relatively early version in terms of the level of automation and task automation and execution. So like, if by agent we mean a chat experience that has a bit more of a lookup and search capability and the ability to ask sort of questions to get the right data and things like that. Right, a little bit more interactive, a little bit more, kind of implicit reasoning. I think we've already seen that. I think that'll, steadily and incrementally grow. If instead we're talking about an agent, like give it a goal and then it'll go off and interact with a large variety of systems and execute without any supervision, like no way, right? There's so many steps with compounded error across that whole environment. Like we can't even get high accuracy basic Q&A in many industry domains yet. Like no way we're going to get that level of automated agent execution. So I think like any story, there's a piece of it that's valid and true and will grow. I think there's a long tail of research that has to be done to get this kind of full fruition of what an agent might mean.
Yeah, for sure. And it's kind of funny. I mean, one of the adages about AI is always like, we don't know what we're talking about. People just say AI to refer to everything. Like, do you mean linear regression? That's not AI. And I think that like almost, it sounds like, Anthony, you're kind of arguing that that's almost happening in the agent market, where it's kind of like the word has become so broad that it's like, are you just talking RAG? Because like if that's the case, then sure, agents exist.
That's right. I agree. It's there's a definite stretching of the definition here.
Okay, maybe I can ask you to jump in. I mean, so are you ultimately, I guess, because Anthony had these two pictures of the world. One is like, is it just a chatbot that looks things up for you? And the other one is like, you tell the agent to do something and it does the whole thing in the real world. Are you kind of an optimist? Like, do you think we're going to get there to that second vision? Or is that going to be like way, way off from your point of view?
So I'm pretty skeptical of the broad definition of agent as it exists today. An agent is really just a long prompt right now. It's like a multi-page prompt where you're asking a model very nicely to do 5 different things and to always think in a specific order and to call APIs a specific way. And it works pretty well, but is not controllable. There's no real thought yet in my mind on like what are the control points that need to be inserted along an agentic workflow in order to have any degree of robustness and reliability deployed out in the world. And ultimately, I think that there's a lot of work to do to transition from here's a 4-page kind of word vomit of everything I want an agent to do, and it goes off and does the thing, to here is a very controllable program that I've executed that has very clear rules, some of which are at the system level, some of which are at the model level, that can go out and execute a series of tasks within a certain degree of freedom, not unlimited. And I worry that right now everyone's just so amazed that if I give a model 4 pages worth of instructions, it can do a reasonable job. I can't read 4 pages worth of instructions and remember everything I'm supposed to do. So, like in that way, yeah, it's really impressive. And I see a lot of excitement and hype being built around it. But if we're not careful, like we're just going to keep going down this road of how do I cram more and more instructions into this prompt for what I want the model to do and not really focus on like what are the control points needed for AI enabled workflows to be automated out in the world, and does chat even need to be a part of them? Agent also I think really connotes like having a conversation or a dialogue, and I think a lot of the opportunities for AI and where we're going to be incentivized to build AI are not necessarily chat based. And so I think just a lot of evolution that's going to be needed for agents to really find their application and actually get traction.
Yeah, it's pretty interesting to hear that. Like, I think like that the chat thing actually might be totally just this kind of mistake of history, and like the long term evolution of this stuff is like actually it's like kind of a bad interface for this stuff.
Well,
Yeah, if I'm writing an
it's,
email, I don't want to like talk to somebody multiple times about what the email should have. I want to like
right.
have just a short little box I put some info in and an email comes out.
I mean,
That's
chat
right.
has been an obsession in AI for decades, right? Like, it's
Well, it goes
part
back
of
to
the
like
original
Eliza,
definition.
yeah, and these kind of things. Right?
Eliza, that's what I was thinking.
Yeah.
Exactly.
That's right. Yeah. Well, again, it's a little bit like to Naveen saying earlier. I mean, it feels really cool. Like,
Yeah.
that's actually a really strong motivator for sure.
It is. And I think part of this is also that we haven't built those models that do what I was saying, right? Actually trying to uncover causality. You can't build something that has quote unquote agency unless it understands the intrinsic causal nature of the world, right? I do this and that happens. Like these models don't have that. They basically can pick up on patterns and extract different sorts of patterns, but they actually don't understand this causal relationship.
So Naveen, I know you're on the show for the first time. I'm starting to get a sense of your vibe, which is that you're grumpy about AI. I'm wondering if I can kind of push
I'm
you
actually
in.
very hopeful. I think it's actually, I've devoted my last 15 or 18 years of my life to this field. So I'm not grumpy. I'm just a
Right.
realist.
Well, I think in the spirit of realism, can I push you on your predictions around agents in 2025? But like, what's the bull case? Like, what do you think the most impactful thing on agents is going to be in the next 12 months, if anything?
Yeah, I think if you basically narrow the definition a bit, we actually get something that's super useful, right? To be clear, an LLM, the thing that can summarize and do all the things that they do, is actually super useful. It doesn't mean it's AGI or whatever. I kind of hate that term, but it is something that is super useful. And I think, as Kate said, the interface is not necessarily a chat bot. Like what I want is something that when I'm in an Excel spreadsheet, I want it to impute values or describe things, or, there's so many ways that you can add value to those experiences. That's what we can do now. And so being able to automate, okay, I want to copy all these cells and then, apply this formula across the rows, or, there's all these kind of tasks that we do. If I could just say, hey, do this for me, that's an agentic workflow, if you will, but it's not thinking on its own. I'm telling it what to do. It just has to carry it out within the framework of the app. So I think that's what we're gonna see more of. And inside Databricks, we're seeing a lot of this now. In fact, we've been using LLMs and generative AI to improve the experience of Databricks itself, like actually finding bugs in your SQL code, or and actually be able to fix it for you, or propose a fix for you. These kinds of things actually are big time savers. So I think that's what we're going to see in 2025 is more of that. And it is going to drive demand for compute and everything, but it's not, super intelligence. That's what I'm grumpy about, maybe, if you want to put a point on it.
Well, I'm glad you said that, Naveen, because it's always a good sign when the panelist is like, I really dislike that term. Moving us on to the third segment of today, let's talk a little bit about superintelligence and AGI. This is the last segment I kind of wanted to focus on, just as we kind of look towards 2025. And of course, it's part of the narrative of where AI is going. The information reported out that OpenAI is seeing sort of the rates of improvement in GPT kind of slowing over time. And I think I caught earlier, there's an interview with Ilya where he basically said, hey, maybe this is actually progress is slowing down. And I think I just kind of wanted to put those kind of rumblings or concerns next to some of what we're hearing from leaders in the industry, right? So Sam Altman did a blog post where he predicted that superintelligence is potentially 1,000 days away. Anthropic recently warned that these systems are advancing so quickly, we need serious kind of targeted regulation in the next 18 months. And so, I guess maybe Anthony, I'll kind of kick it to you first is, what are we to make of this, right? Is AGI on the way? Is this kind of how do we kind of square a lot of what we've been talking about this episode, which is, it's going to get harder with, I think, kind of some pretty strong claims that hey, we're about to have ultra powerful systems, in the next 1,000 days.
Look, we're talking about it, so the headlines work, right? It's a compelling topic. It attracts the public's attention. It's like the superhero obsession, or whatever you want to call it. I think a lot of it is that. Right? Look, where are we today? I don't even know what a working definition of AGI is at this point. I can propose my own, but I think what we're going to start to see really matter is more and more ways that AI is integrated and embedded and helps in specific contexts, right? So Naveen mentioned some, certainly coding assistants, embedded coding assistants have made a lot of progress. It's kind of an early set of use cases. We've seen lots of utility. We'll see a lot more of that. Look, in terms of when does AI reach some level of general intelligence? Even if we take a definition of that being equivalence to human capacity to not only, know things, but to reason, to perceive, that's a very long way off, I'd say.
Yeah, I don't know if it's I guess it depends on what you define as a long way off. I think we will get there. It's just going to be harder than we think. So our perception is very linear. It's okay, this thing has been going, and every year it gets better and better and better. So then by 2 more years, we're going to have this other thing. That's not actually how these technologies seem to evolve. And that's never really been true. And so we always underestimate or overestimate the technology in the short term, but underestimate it in the long term, because they actually work on exponentials. So 10%, 5% improvement a year on year of something actually adds up a lot, very fast once you get to year 7. So I think what we're going to see is in 10 years, we very well might have something that does reason and actually does understand causality. My prediction has been I think by 30 years, it's a 95% chance we will have solved that. By 10 years, I think it's like a 30% chance. So that's kind of my bounds are 10 to 30 years from now. But I think that's not that long, right? So
Yeah, like you're kind of saying, like, there's people alive today who will definitely see that.
yeah,
right?
totally,
Like,
right?
yeah.
I mean, which I think is very cool. But it's not something that's going to happen next year. I think that's just a hype train, to be honest with you. We haven't solved fundamental problems yet. And we will see around that precipice a year ahead of time pretty clearly. And right now it's not super clear. So to me, it doesn't feel credible to say that.
Well, I think we're also conflating a lot of things like cause and effect and causal understanding versus super intelligence. Like there are causal models that are out in the world today that can help break down and isolate cause and effect relationships and things, particularly in like drug discovery, that are widely used. You know, so are we just talking about can we get the models to better understand causal reasoning, or are you talking about sentience and in like every stretch of the world and having a model that has a personality and goes off and does things of its own will, so to speak? And I think that in general those aspirations are really more around marketing, and I don't think there's even necessarily the right economic incentives to develop that versus developing cause and effect reasoning, but developing better tools for handling language and doing different tasks. Absolutely. I think in the next 3 to 10 plus years is more realistic.
Yeah, there's this adage in kind of financial markets that like the market can be irrational longer than you can stay solvent. And I was joking with a friend recently. It's like AGI can be imminent longer than you can stay solvent. It's like it's just around the corner. Everybody, believe me, it's just around the corner. Um, I guess Anthony, maybe to go back to you. I mean, I want to kind of challenge the idea that it is potentially just all marketing, right? I think one of the really interesting comments that came out of this kind of essay that Dario Amodei, who runs Anthropic, wrote. We were talking about it a few episodes ago. He's writing about the future of AI and how it's going to change the world and everything. And a lot of people say, marketing. And some people kind of looked up like his writings from when he was like a grad student, and he's like still writing about this stuff, right? And I do think that that is kind of an interesting thing that I would love to kind of get your thoughts on is like, it almost feels like in order to be able to look past all of the current problems with the technology, you almost kind of have to be a true believer in some sense. And like, in some ways, like, I actually don't know if like, it is marketing coming out of some of these companies. Like, I think they do genuinely believe that it is imminent. I don't know how you think about that.
I think AI is going to change the world. I think it's going to change it incrementally, practically, and pretty quickly, and it already is. In all the practical ways we've talked about, specific applications, integrated with software, integrated with capabilities that we want assistance with. No, I wouldn't say that people are like disingenuous. I just think that there's this cultural kind of continued obsession with, intelligent, super anything, right? And it's interesting and it's fun. Another kind of more negative side of that is, the whole existential debates that have hopefully started to die back, I think. But you saw that like, a year and a half ago, especially like really, really with a lot of heat. Yeah, I'd say that it's just kind of so natural and attractor. Like it's hard not to bring it up. But look, I don't know, maybe I'm just too much of a pragmatist. I just try to focus on all the ways that AI is actually helping and will help, like every day, like on this podcast, probably before too long. It's just, to me, that's how the world changes, not with some super intelligence.
Well, and I think what's interesting is I agree with you. I don't think they're being disingenuous. I think people really believe it, and that's fine. But we want to pull back and contextualize a bit. Like, do you care that the airplane was invented in 1903 instead of 1910? Does it really matter? It doesn't, right? I mean, we're splitting hairs a little bit. Like, why am I right and someone else is wrong? It actually doesn't matter. Like, I think if it's 3 years, like as Dario says, or it's 10 years, if you look back at 50 years, it doesn't matter, right?
Right.
Because of exponentials, So I think it's okay. It's okay that we're exuberant and we believe.
I also think some of Anthropic's warnings, so to speak, and the need for safety and better understanding of these problems aren't necessarily just predicated by the arrival of dumb intelligence can be pretty dangerous if it's out in the world, right? If we're starting to give LLMs all these API calls and ability to impact the world and pull real data into their decision making. So, as we talk about it being genuine, I think from that perspective, it absolutely is true, and something that everyone should be aware of, regardless of is this quote AGI or super intelligence or not.
Yeah, for sure. Yeah, I think that these last two comments are really interesting because I think all three of you kind of would pitch yourself as like realists in the world of AI. But kind of where we're almost landing is, look, we're all agreed this technology is going to be a huge deal. We're just hair splitting over whether or not it's going to be 10 years or 2 months from now, which I think is a pretty interesting outcome. Yeah. Um, Maybe the final comment I'll kind of throw in because I'm just kind of curious to get all of your thoughts on this is, to talk about realism, like all three of you are talking to customers that are in the market, people that need to just basically wake up in the morning and be like, is this technology going to be better than what I currently use in my stack? And should I implement it? Like, do you hear from customers? They're like, and by the way, Anthony, should I be worried that this technology is going to destroy the world? Like, I'm kind of curious about how much of this is kind of sort of chin stroking media discussion or how much of it actually is like influencing actual enterprise decisions and discussions happening on the ground, or if those two are basically like completely separate worlds in some sense.
Certainly, lots of customers are concerned and ask questions about accuracy, about trust in systems, about how to implement specific use cases, right, with a high quality of output that they can trust in deployment, that they can save money or make money on and not have a big liability with. And there's lots of challenges across the board in all sorts of domains, right? In health, in finance, in legal, in many, many areas. I hear very little, if any, questions about their, helping AI, destroy the world, right? These big existential kind of, if I deploy AI, am I going to, contribute to the robot army that takes over humanity? Like none of that stuff, right? It's very practical. It's business focused, as it should be, right? That's what I hear.
That's so interesting to me is kind of like we think about the AI discussion as being like kind of one block, but I think in practice, it's actually these like pretty distinct, kind of like fora in which these discussions are happening. And okay, Naveen, if you got thoughts on this, on like what you're hearing from customers and whether or not this AGI stuff even kind of like registers at all.
Yeah, I mean, I think Anthony nailed it. It's very practically grounded. That being said, I think the motivations are such that I don't want to be the one who didn't jump on the train and made the company get left behind, whatever that company is, right? And so there's a lot of tops down push for getting AI coming even from the boards. I've spoken to multiple boards of very large public companies, and that this is a discussion front and center there. And it's really about, this is the next technology transition. We have to be part of it. No one's really talking about like, is it going to take over the world or whatever? It's just like, how do we craft a strategy such that we are part of this new world?
Yeah, I'd echo both of those statements. And I think overall, what I'm really optimistic about, honestly, is that a lot of the conversations with enterprise is about how do I take advantage, but how do I also make sure I've got the right protocols, the right control points, the right safety measures in place? Because I mean, their bottom line is ultimately at risk with the deployment. And I think that provides a lot of really helpful and healthy pressure on model providers to develop the solutions that are needed for a more responsible and governed approach versus a just build as far and fast as you can. And so I think that is going to ultimately help us create a lot of the tooling that's needed so that it isn't necessarily the concern that AGI is going to take over the world. We will have hopefully built the right controls and processes in place to be able to have a very well-governed AI system.
Yeah, I can't think of a better note to end on than that, Kate. So thank you. So I'm going to wrap us up for today. Kate, as always, thanks for coming on the show. Really appreciate it. And Anthony and Naveen, we hope to have you on the show in the future, hopefully. Thanks for joining us. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we'll see you next week on Mixture of Experts.